Hi there, let me start with the project files and the project. So first of all, let me start with the without DG calculation. So this is the script, this is the code without DG, and our case is 33 bus system. You may change it to 69 bus system easily. Just you have to change these numbers 33 to 69, and that's it. So this is the without DG code. Here in this project we have line and load data for 33 bus system. Okay, so when I have to run this program, this is without optimization, without DG. So at the end of this program, here you can see that I have real and reactive powers, and I have voltage at each bus, real and reactive losses at each bus. And this is a base case. This is the first case without DG. So now I copy these results into without dg.m file. So later on I have to compare these results with the other approaches, I mean the hybrid case or the individual PSO and the genetic algorithm case. And let me open the PSO case. So here is the PSO case. So in start of program, we have how many DGs you want to consider. So you can go with 2, 3, 4, so 5. So and the number type of DG. So the if you place number 1, it means you want to choose real power only. Sorry. And if you want to choose reactive power only, you have to consider DG type 2. And if you want to consider real and reactive both type of injection, you have to type 3 here. Okay, and that's how the program will work. And here in the start of the program I have mentioned the minimum and the maximum. So this is the minimum size and maximum possible size for a DG which I have set for this program. And the location for our DG, here you can see that the location is minimum 2 and maximum is 33. So we have set our minimum and maximum sizes and location for our DGs. And in previous lines we have defined which type of DG you want to incorporate and how many DGs you want to incorporate. So this kind of instruction is similar for even for hybrid case up to this point, and even for genetic algorithm up to this point. Okay, and next there is a start of the PSO parameter, and in that PSO parameter we have cost function calculation. So let me open the cost function. So we have here our cost function, which is actually the sphere. So now we are going into the sphere file, and in sphere file we have our load flow. So in sphere case, load flow case, we have to inject our powers. So in case of PSO we have already selected our DG types and the number of DGs. By using, in case of PSO we will incorporate or add DG using the PSO optimization, and in case of genetic algorithm we will do injection using genetic algorithm approach, and in case of hybrid we will apply that in a similar way. So in sphere case we are going to add our generation, I mean PG, real generation and reactive generation. So if we have our first case real power injection, we will do real injection. In case of reactive power we have reactive injection, and for the case third, which is real and reactive injection, we have this case. So that's how we have to inject our powers. And then we have our load flow program, which is similar to our base, I mean the base case. But the difference is between both these is that here in case of PSO GA hybrid we have then injection in the start of the program. And at the end of this program, we have to sum up the losses at each bus, and we have added the voltage deviation here. This VD is voltage deviation, so this is our cost function. So another file, that is load flow 2 file, which let me show you in case of PSO. So at the end of this program, when we have evaluated all our iterations, so this is the line start maximum iteration. So when we have ended our maximum iterations, now we have the best location. So this is the best location which this is the best location and size which we have to put into our load flow 2 file. So let me open the load flow 2 file here. So in load flow 2 file, we have injected the best results which we get previously from any optimization algorithm. So now we injected that powers. It's exactly similar to the load to the sphere case, but the difference is that here in load flow 2 file we get our best sizes and locations. So in this load flow 2 we have to compare our results here with the base case without DG files, without DG results. So now we have hybrid case. So let me run the hybrid case. Okay, at the moment let me reduce the iterations 100, but I will suggest you to choose around 300 iterations. So let me click on run, and when I click on run, program will start. And for first iteration we have this best cost. Okay, so previously I have explained a little bit about PSO. Let me explain a little about hybrid. So we have problem definition, which I have explained previously. Now we have PSO parameters, and then we have some variable initialization. We have started our PSO algorithm here. We have find cost for our initial phase, that is related to PSO. And then at this point we have considered the genetic algorithm part. So this is the part which is about genetic algorithm. This Rowlett wheel selection, this is about related to genetic algorithm. And here you can see that we have our iterations ongoing. So genetic algorithm is ongoing. So here we get our results. So let me show you first the plots. This is the convergence curve. So initially we have higher cost. Here cost means the power losses, and as our iterations are moved, we have best cost, means we get the sizes and locations which have better cost. And the second here is the voltage profile. This is blue line without DG and this pink line with DG. And the third one, this is the power losses. Sorry, this is the voltage profile, this one, and here this is the power losses. So comparison between without DG and with DG case. And here you can see results. Previously without DG we have these powers, then by using DG we have these powers, optimal locations, optimal sizes, voltage deviation before DG, voltage deviation after DG, and this is the which is actually the demand for our network, which will be same for each case. And here above you can see that we have our line currents, and we have our loss at each bus, and here we have voltage profile at each bus. So here in this program you can see we have genetic algorithm, and at the end of this program we have evaluation for these results. So that's how this program work. Another thing, you may change number of DGs and the type of DGs as per your requirement. So that's how you can evaluate the results. Hopefully you get an idea how the program will work. and later on you may compare the results with hybrid BESS or GA, and that's it. So thanks for watching. If you have any other query, you may send me an email.